In this video, I'm going to demonstrate some examples of solving quadratic equations using square roots. Oftentimes you'll see quadratic equations where you want to factor. That's great. You can use the quadratic equation sometimes. If you can't factor, again, that's great. But there are times when using and solving with a square root is really the fastest method. What you want to look for in your equation is that you have one variable and it's only being raised to the second power. That's basically what you want to see. So in a standard form quadratic, standard form, remember I'll write this up at the top, is ax squared plus bx plus c, where a, b, and c are all integers. In standard form, you have both x squared and an x term, which is why we either need to address this with factoring or with using the quadratic equation. In this first example, you'll see we only have n squared. There is no other n term, so that's what allows me to use solving with square roots. So how am I going to do this? Well, I'm going to get that n squared by itself. So I'm going to subtract 2 from both sides, and that gives me n squared is equal to 100. Everything in math has an opposite operation, and the opposite operation to squaring something or raising something to the second power is to take what's called a square root. So I'm going to take the square root of both sides. The square and square root cancel each other out in the same way that adding 2 and subtracting 2 cancel each other out. And so now what I'm left with is, on the left side I have n is equal to, and this is the place where people make the biggest mistakes. They will write down, well, the square root of 100 is 10. They will put a box around that answer. They will give themselves a little pat on the back, and it is entirely possible that you will get the problem wrong. Because when you put a square root into the problem, or in my case, when I wrote this square root into a problem, that actually means I need both the positive and the negative square root. So the positive square root of 100, positive 10. The negative square root of 100 is negative 10. Both of those answers are valid. And if you want a little reminder about that, if you were to take 10 and square it, you would get 100. 10 times 10 is 100. Okay? If you took negative 10 and squared it, you would still get 100 because you would be taking negative 10 times negative 10. All right? So that's where you want to be really careful with these, that you make sure you include both answers in your solution set. Okay? So that's the first question, right? First little example here. Let's see what the next one brings. So first thing I want to look for is, yes, in fact, I just have m squared. There's no other variable m in the problem. All right, I want to get that m squared by itself. I'm going to add 2 to both sides. So m squared is equal to 26. Okay. We just talked the opposite operation to squaring something is to take the square root. Okay. So on the left side, we've got m is equal to, immediately after I write down that equal sign, my brain immediately says put the plus minus sign down so you don't forget it. Now, I have the square root of 26. The square root of 26 is a decimal answer, and depending on what you're asked for is going to depend on whether you put square root of 26 in your calculator and you would get 5 point, a whole bunch of decimals, or if you just leave it as the exact answer of root 26. For my purposes, I am completely happy leaving it as plus or minus root 26 for that m value. So this tells me I have 2 values for m, positive root 26 and negative root 26, 2 answers. All right, example number 3 here, same kind of setup. I want to get b squared by itself. I want to isolate that variable. So I'm going to subtract 6 from both sides. So b squared is equal to 20, wow, that's a horrible 2, 25. I'm going to take the square root of both sides. So I've got b is equal to, immediately put that plus or minus in so you don't forget it. In this case, 25, square root of 25 works out to be a perfect integer value of 5. So sometimes you get integer values like this, plus or minus 5. Sometimes you'll have square root answers, plus or minus root 26. Really doesn't make any difference in these solutions. All right, example number 4. So I have exactly 1 r squared here. There's no other r terms, so I can go ahead and use my square roots. But I need to get that r squared by itself, so I am going to divide both sides by negative 4. So that's going to give me r squared is equal to 1. To undo a square, I'm going to take the square root of both sides. So r is equal to plus or minus the square root of 1 is 1. So it's nice that we could do that. Okay. So those first 4 examples are done. Let's take a look at the next set. Well, these look interesting. All right, so problem number 5. First things first, if I want to solve this, this is actually supposed to be a 0. That's a typo on my part. My apologies. All right, so now that I know that's actually supposed to be a 0, I'm going to solve for x. So basically I want to peel away the extra stuff that's around it. So the furthest thing here is I'm going to get rid of this minus 1 by adding 1. Okay, add 1 to both sides. So 0 plus 1 is 1 equal to x plus 4 squared. Okay, it looks a little bit weird because we've got the parentheses set, but do the same thing that we've been doing. I need to get rid of this power now. So I'm going to take the square root of both sides. Okay. Square root of 1 is plus or minus 1. Again, I put that square root in the problem, so I need to account for both the positive and the negative root. On the right side, the power of 2 and the square root will eliminate each other, leaving just x plus 4 behind. But x is still not quite by itself. So last step here in terms of getting x by itself is to subtract 4. Now, this is place where students make pitfalls, place where people make pitfalls, is I've seen people in the past just take, 1 minus 4 is something, and then put a plus minus in front. You can't do that, okay? So what you want to pay attention to is you've got negative 4 plus or minus 1. This breaks up into 2 different examples. So 2 different answers. You've got 4 plus 1 is equal to x, and you have negative 4 minus 1 is equal to x. Each one of these you are going to simplify separately. So negative 4 plus 1 is going to get me x is equal to negative 3. Negative 4 minus 1 is going to get me x is equal to negative 5. So those are my 2 answers. I have a tendency to write x is equal to something, comma, something else. Don't use parentheses or any other grouping symbols around it. It's just a list of values for x. Okay. So that's that particular problem for example 5 here. Let's see what the next one looks like. Similar kind of problem. Again, I made that same typo, so let me do a quick fix here. That should be 0. If it wasn't 0, you actually wouldn't be able to solve for x, or if it wasn't a number, you wouldn't be able to solve for x, so it has to be a number. I want to get x completely by itself. So there's my x. Let's start taking out the pieces. So I'm going to get rid of this plus 4 at the end by subtracting 4 from both sides. So 0 minus 4 is negative. 4 is equal to negative x minus 4 squared. How do you get rid of this negative sitting right here? Well, this negative represents a negative 1. So we could divide both sides by negative 1. So 4 is equal to x minus 4 squared. let's go that color. To undo a square, I'm going to take the square root of both sides. The square root of 4 is plus or minus 2. On the right side, the square and the root cancel each other out. So we've got x minus 4. Okay. To get x completely by itself, I'm going to add 4 to both sides. And again, be very careful with this. I tend to write it out so I can remember the two parts to my answer. So I'm going to put this off to the side here where I have a little room here. So it's got 4 plus 2 is equal to x, and 4 minus 2 is equal to x. So 4 plus 2 is x could equal 6, or 4 minus 2, x could equal 2. And both of those are completely valid answers for this problem. Okay. All right, I believe I have 2 more quick examples. Let's see if they do the same kind of work here. And that's my little typo there. That should have been a 0. All right, solving for x. All right, here's my x. Let's go ahead and add 2 to both sides. Just starting to peel away the numbers and the various operations that are attached to x so I can get that x by itself. So 2 is equal to 2 times x plus 1 squared. I'm going to divide by this 2 in front. So I've got 1 is equal to x plus 1 squared. To get rid of the power of 2, I'm going to take the square root. Square and square root cancel. Square root of 1 is plus or minus 1. And then I've got x plus 1 on the right side. But of course, there's more. And I'm actually going to show you a slight option you might want to take here. One way that I've seen people pay attention to the plus minus so they don't screw it up in the finale piece of this is to actually take your equation here and split it up into 2 parts. So you would say positive 1 is equal to x plus 1, and then your other equation would be negative 1 is equal to x plus 1. So that's an option if that might help you keep track of the fact that you have 2 answers and how to deal with it at the end when you have that plus minus. Really depends on what makes sense for you and what you prefer. Let me go ahead and solve for x. So I'm going to subtract 1 from both sides. Subtract 1 here. All right. So x is equal to, well, 1 minus 1 is 0. And in the last equation here, x is equal to negative 2. So I like boxing up my answers, so if I go looking for them later on, I can find them. So those would be my answers. X is equal to 0, x is equal to negative 2. And now let's take one last look at what happens in a similar problem, but maybe a little bit different in the solution. Again, my typo here, my apologies, that should have been a 0. Okay, peel away the pieces attached to x, subtract 3 from both sides. All right, so negative 3 equals negative x minus 2 squared. To get rid of the negative, remember this is negative 1, so I'm going to divide both sides by negative 1. So 3 is equal to x minus 2 squared. I'm going to take the square root of both sides. Immediately, I'm going to put a plus or minus down. I'm going to take a pause here for a second because here's the deal. The square root of 3 is a decimal value, and it's not a very pretty decimal value either. So this would depend on what the directions say. These directions just said to solve. I am going to go for the exact answers here, as weird as it's going to look. I'm just going to leave this as root 3. If the directions had said find the approximation, round your answer to 2 decimal places, use a calculator. On the right side, square and square root cancel, so I've got x minus 2. Now you could split this. I'm actually going to leave this as one equation and just deal with it as it's written. So to get x completely isolated, completely by itself, I'm going to add 2 to both sides. So that's going to cancel out. So I've got x is equal to, now this left side, I've got a positive 2 and a plus or minus root 3. It is completely okay to write down 2 plus or minus root 3. That represents the two answers that x could equal. It's basically a lazy way to write it. So instead of writing 2 plus root 3 equals x and 2 minus root 3 equals x, which, by the way, is the exact same answer, feel free to put just the 2 plus or minus root 3. All right, so these were a lot of examples in one video here, but all of them were dealing with solving quadratic equations by taking square roots. So remember, you need to make sure that you just have a single variable that is being squared, and you will be able to use this method.